Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to everyone who is watching this video. Me and my teammate Tan will present our findings on this PBA CA. Before we start, I'd like to introduce each of us. My name is Muhammad Faizzudin, Muhammad Aisan, and my matrix number is DIT 25 DIT 24110X7.
And my name is Tan with my matrix number F1044. So now we will go straight to the question. So here I will show you my calculation for the instruction. This is the instruction, which is okay. So my calculation is, first I will do Mulu operation, D4, D5. So D224 times 0010 equals to 488, and it will be stored in T5. So add dot W D4 D5 D4, then we will use its value, which is we will use its value, which is 5678.
Pakai ni. Dia just buat tukar-tukar je. Okay.
So add the W D3 D4. So 5678 plus 2244, which equals to 78 BC, and it will be stored in D4. However, that is only 4 digits. So the front digit will be the same. Will be AABB. So AABB 78BC will be stored in D4. AABB will just stay constant. So next we're going to perform sub dot B D5 D4, which is BC minus 88 equals to 34 stored in D4. It is 2 digits, so we're going to replace the 2 digits behind. AABB 7834 will be stored in D4. Not L D4, and AABB 7834 will be converted to binary form, and we will perform the NOT operation on it. And the result we get is 5544X7CB, and it will be stored in D4. After that, we're going to perform the swap operation, which the result is X7CB 5544, which will be stored in D4. So next, we're going to look at our 68K program. This is our instruction. So first of all, we're going to move 1, 2, 3, 4, 5, 6, 7, 8 into D3. And yeah. Then we're going to move AABB2244 to D4. Next, we're going to move the 0010 binary number to D5, and it'll be equal to 2 because base 16. So we're going to perform Mulu operation next on D4 and D5. Then the result will be stored in D5, which is 4488. Stored in D5. After that, we're going to perform the add operation on D3 and D4. So the result 78BC will be stored in D4, and AABB will just stay the same. It's not affected. So next we're going to perform add the W D3 D4. Then the result is going to be 78BC stored in D4. 7834. BC stored in 3-4 here. So BC stored in D4. And then next, you're going to perform the sub operation, which is D5, D4. Then the result will be 34 stored in D4. See? 7, 8, 3, 4. Next, you're going to perform the NOT operation, and the result will be stored in D4, which is 554478 CB. Stored in D4. Next, we're gonna perform the swap operation, and we're gonna swap its numbers in D4. And then our program will end here. And next, I'm gonna pass you to my teammate for question 2 and 3. There we go.
Okay, so for question 2, we're going to refer to the exhibits. The exhibit goes y equals to not open bracket BCDC base 16 times 1010111 base 2, and then minus 363 base 8 close bracket. So as we know, we must first perform the operation inside the bracket before we go into the outside of the bracket. So we have three instructions, which is to write an instruction set to solve the provided equation. Second, to show the output of the Easy68K simulation software for each line command, and then we're going to provide a comment to explain the expression of each line. First, to determine the answers to the exhibits, we can we're going to write the lines of code needed to perform the operations to get the answer. So first, we're gonna set the starting address to $1000. Next, we're gonna move W BCDC to base 16, base 16 to data register in D1. Since it's already in hexadecimal value, so we just put a dollar sign indicating it is in base 16, so we don't need to convert it. Move it to data register D1 by word size, and we're going to, after that, we're going to add the binary numbers, which is 10101111 base 2, to the data value in to the value in data register D1 by port size. After we get the answer, we're going to subtract the three. We're going to perform the subtraction operation of the value 363 base 8 to the latest value in data register D1. After we perform this calculation, which is inside the bracket of the referring to the exhibit, only then we can perform the bitwise operation, that is not not operation on the value in D1. And then we end the program after we get the final answer. So this is the actual simulation. First, we're gonna set the starting address to $1000, and then after that we move the hexadecimal value BCDC base 16 to D1. After that, we're going to add the binary value 101011 base 2 to the value in data register D1, which we get BD 33. And then we're gonna subtract the value in D1 by subtract it to the octal value 363, which is subtracting the 363 with base 8 value to the latest value in data register D1, which we get BC40. base 16. And we're gonna perform the bitwise operation, not operation on the latest value in the data register D1, and the final answer we get the 43BF base 16. And we're gonna end the program. So the comments for each line that determining this each steps, what will it do and how will it do. So the first is referring to the org $1000. It is to set the starting address to $1000, and then we're gonna load the hexadecimal value BCDC into register D1 by word size. After that, for the add.w operation, it means we will add the binary value 1010111 to the value in register D1 by word size. After that, for the sub.w operation, it means to subtract the auto value 360 to the value in register D1 by word size. After that, we're going to perform a bitwise NOT operation on the latest value in register D1 by word size. And then we're going to end the program with the final answer for 3BF base 16 in D1. And now for the question 3, we need to write a program to calculate the area of the rectangular below. Justify the result through calculation and simulation result. Given that A is your age and then B is your height, so we're gonna use my age and my height. First we draw the rectangular, and then using my age and height, we got A equals 18 and then B equals 175. The area of a rectangle is close to the A times B. So put the value in the formula, we get 18 times 175 equals to 3150. This is the value in decimal, which is base 10. The answer will look quite different when we use the easy staircase simulation, but the answer will mean the same thing. Now we use the same commands, but a little bit different on operation method, operation option that we use. First, we set the starting address to $1000 as usual, but then we're gonna move the 18 value to register D0 by long word size. Notice how I didn't use the anything after the hashtag and then immediately use 18. It means the 18 is in decimal base 10, which the simulation will convert it into hexadecimal value later, and then move the 175 value to register D1 by word size. Also the same as 18. Also doesn't have anything after hashtag, immediately write down hashtag 175. We will convert it to hexadecimal value later on. After we have the value in each register, we're gonna perform the modulo operation, which is the multiply operation between the value in register D0 and the value in register D1 by word size. After that, after getting the answer, we're gonna move the latest value in register D1 to register D2 by word size. It is to make for easier indication and monitoring. So this is the simulation result on the same page. We're gonna set the starting address to $1000, and then we're gonna move the uh, 18 value to register D0. As you can see, it immediately converts it to hexadecimal value, which is 12 base 16. And then we move the 175 value to register D1 by word size. Also the same, it immediately convert it to hexadecimal value, which is AF base 16. And then we perform the modulo operation between value in register D0 and value in register D1 by word size. So we got the answer C4E base 16. And then After that, we're gonna move the latest value in uh, register D1 to register D2 by word size. As you can see, the value is now also in the register D2 for easy monitoring and indication. Then we're gonna end the program. So before more operation, the value in D0 is 12 base 16, and in D1 equals to AF base 16. So the calculation goes the value in D0, which is 12 base 16, times the value in D1, which is AF base 16. The answer is C4E base 16. So after the mulu or multiply operation that I just said, the value in D0 remains the same, which is 12 base 16, but the value in D1 is now C4E base 16. Since the formula goes source times destination equals destination, the latest value will be stored in register D1. Then we're gonna move it to D2. So after move operation, the value in D0 and D1 remains the same, which is D0 equals 12 base 16 and D1 equals to C4A base 16. But the value in register D2 is now also C4E base 16, just like D1. But before the move operation, the value in register D2 is actually 0. Now, after we got the final answer, to determine is actually the right answer that we do, which is 3,150. We're gonna do the conversion from hexadecimal to decimal value. Now C4E base 16, pardon the same size is supposed to be subscript, indicating base 16, base 2 and base 10. Now the C4E base 16 equals to the convert it to binary. We got 11000 100 and now we convert from binary to decimal, and then we got 3,150. So 3,150 is actually the same value that we got from calculating the initial manual calculation phase, which is to determine the area of the rectangular. That is 18 times 175 equals 3,150. So all of this, it means that it is the same answer and the simulation runs correctly, and C4E base 16 equals to 3,150 base 10 or decimal. That one is for the question 3. Now for the fourth and last question, I will hand it over to Tan to explain it until finish.
So here we're gonna do the AND operation for, sorry, not AND. We're gonna do the OR operation for A and B. So, okay, the OR operation for A and B. A is A, B, C, D. B is 1, 2, 3, 4. Then we're gonna convert these two into binary form. After that, we will perform the OR operation with the result ABDD stored in D1. With the result ABDD stored in D1. So after that, we're going to do the NOT operation for C. So you're going to take the value stored in C, 100111100, and we're going to perform NOT operation on it, which gives us the result 63 stored in the D2. And then we're going to do the AND operation for A and C. A and C. A, B, C, D with the result of C, which is 0110011, and the result, first we're going to convert these two to binary form, then we're going to perform the AND operation on it, After that, we will take the result and store it in D2, which is 41. Then we will perform the AND operation on the result of AB and the result of AC. So, AND ABDD 41, convert it into binary values, result equals to 41, which is the same. And store in D2. Then we're gonna perform the NOT operation on 41 equals to BE in D2. We will store BE in D2. We perform the NOT operation because it's a NAND logic gate. Of that, this is my code, this is my instruction for the question. So first, our instruction will move ABCD to DO, D0. Then it will move 1, 2, 3, 4 octal in D1. 290 it is its base 16 value. Of that, we're going to move the binary number 100 into D2. And BC is its hexadecimal form. 9C, sorry. 9C is its hexadecimal form. Then we're going to perform the OR operation on DO D1, and the result is going to store in D1. There we go, ABDD. After that, we're going to perform NOT operation on D2. The result will be stored in D2, 63. See? And then we're going to perform NW on DO and D2. Result will be stored in D2, 41. And we're going to perform AND operation again on D1 and D2. And the result will be 41. It will be the same, no changes. Then we're going to do, lastly, we're going to do NOT.B on D2. After that, it will give us BE in the data register 2. And that's the end of our program. And that's all from us. Thank you.
That's all from us. Thank you. I hope it is bit helpful. Thank you.
Bye.
Bye.